All right, Algebra 2. So yesterday we learned how to factor a trinomial. Today we're going to be solving a trinomial. So when you have to solve, that means that you are going to have an equation. Yesterday we had an expression. There was no equal sign. Today we have an equation. So we are going to take what we did yesterday and add on to it. Step number 1, you always have to make sure that your equation is set equal to 0. In problem number 1, yep, all of my variables are on the left side, it equals 0. When we get to number 2, no, we're going to have to fix that. So set equation equal to 0, check. All right, so I have to factor it. So when I look at this, everybody has an x, and so that is what a GCF kind of problem looked like yesterday. So I'm going to factor out the GCF. What's the biggest number that divides into 6 and 9? So that would be a 3. So a 3 is my number part of the GCF. For the variable, the GCF of the variable is always the smallest exponent. So my GCF is 3x. Remember to bring down your GCF. And now we're going to divide. 6 divided by 3 is 2. X squared divided by x is x. Bring down your plus sign. 9 divided by 3 is 3, and your x's cancel out. We use this thing called the zero product property. So once you have your terms factored, step 3, we're going to set each factor equal to 0 and solve. All right, so I'm saying that 3x is one factor and 2x plus 3 is a second factor. So I'm going to break those apart. Now I'm going to write one equation of 3x equals 0 and a separate equation of 2x plus 3 equals 0. Now we're just going to do algebra. So 3x equals 0. That means I'm going to have to divide both sides by 3. And 0 divided by anything is 0. So x equals 0 is one answer. The other one, I'm going to have to subtract the 3 over. Get 2x equals negative 3. Divide both sides by 2. And x equals negative 3 halves also. Fun fact. Sometimes we call these the solutions. When we graph them, they are also the x-intercepts. Some questions might refer to them as the roots, and some might refer to them as the zeros. There are slight differences, but as far as Algebra 2 is concerned, all these are the exact same thing. Another fun fact, whatever your biggest exponent is, that's how many answers you have. So you have an exponent of 2. That means that you will get 2 solutions. So 0 and negative 3 halves are my 2 solutions. Number 2, we said it had to be set equal to 0. So I'm going to subtract my 21n over to the other side. These are not like terms, so I'm just writing it down. once I've done that step, now it basically looks just like number 1. There's only 2 terms. They each have an n, so I know that this is a GCF kind of a problem. All right, the biggest number that divides into 7 and 21 will be 7. And the GCF of your variables is always the smallest exponent. So I'm going to bring down my GCF, and now I'm going to divide. 7 divided by 7 is 1. When you divide variables, you subtract exponents, so that just gives you n. Bring down the sign between them. 21 divided by 7 is 3, and your n's cancel out. And if you look up here, it says, set each factor equal to 0 and solve. So 7n is one factor, and n minus 3 is your second factor. So I'm going to break them apart and write my 2 equations. One of them is 7n equals 0, and the other one is n minus 3 equals 0. Do algebra and solve. So I'm going to divide both sides by 7, and n equals 0. Add the 3 to the other side, and n equals 3. My biggest exponent was a 2, therefore I have 2 answers. Next one. All right, so this time I have 3 terms, and so I'm going to perhaps review my factor of trinomial notes from yesterday. So I'm going to make an ACB chart here. So 1 times 20, I need factors of 20 that add up to -9. All right, so I know that 4 times 5 is 20, and they add up to 9. Oop, they got to add up to -9. Okay, so -4 and -5, those are also factors of 20, and now they add up to -9. So this factors as x minus 4, x minus 5 equals 0. So this is one factor, and x minus 5 is another factor. I'm going to set my factors equal to 0 and solve. So x minus 4 equals 0, and x minus 5 equals 0. So I'm just going to do algebra. I'm going to solve for x. So x equals 4. Add your 5 over, and x equals 5. My biggest exponent is 2. I get 2 answers. This next one, set each factor equal to 0. Set your equation equal to 0. If a is a negative number, we're going to move it to the other side. Or you can always divide by -1. But before you factor, your a must be a positive number. Factoring is very, very hard when your a is a negative number. So I'm going to add x squared to both sides, and I'm going to subtract 13x from both sides. So I made the left side add up to 0. Ooh, this is all messed up. You also have to make sure you write it in standard form. That means your x squared comes first, your x term comes second, and your constant always comes last. So it has to be this way in standard form. Once you have it in standard form, now I'm just going to make an ACB chart. I need factors of 12 that add up to negative 13. So 1 and 12 is 12, and that adds up to 13. Oh, needs to be negative 13. All right, so that means that they both have to be negative. That adds up to negative 13. So this factors as x minus 1 and x minus 12. Break it apart, write your two equations, x minus 1 equals 0, and x minus 12 equals 0. Add 1 to the other side, x equals 1. Add 12 to the other side, and x equals 12. Hey, super fun fact. If you compare your factors with your answers, do you notice something about the signs? From factor form to answer, are they the same or different? So these are different. Let's see if that's true on the other one. This had a factor of x minus 4. That was a positive 4. That had a factor of x minus 5. That has a positive 5. So, fun fact, from factor form to answers, you always have a sign change because you're always adding or subtracting your number to the other side. And this is a good place to stop, and we will do the back side on part 2.